Hi guys, this video we're going to look at different ways to represent data. We're going to look at how to use histograms, dot plots, and stem and leaf plots here. Okay, so one thing we need to know is what's the difference between quantitative data and qualitative data. So quantitative, quantity, you can kind of hear that root word in there, means that it's measurable. So we're taking observations or collecting data on things that are numbers based or we can count them. Qualitative data is data that, or observations of things that are more descriptive and less easy to measure with just numbers. Okay, so one of the things we're going to do is we are going to use histograms, which is kind of the more formal word for bar graph, to represent some of this data. So this table here is the number of calls per day to a fire and rescue service for 3 weeks in a given, for 3 weeks is given below. Use the data to complete the frequency table. Okay, so frequency is how often does something occur. So 5, I'm going to kind of cross these off as I go. 5 falls between here and here, so I'm just going to kind of use tick mark. 17 here, 2, 12, 0, 6, 3, 8, 15, 1, 4, 19, 16, 8, 2, 11, 13, 18, 3, 10, 6. Okay, so I am going to look at making a bar graph to represent this. So you can kind of see we have 5 different ranges here. So I've got from 0 to 3, 4 to 7, 8 to 11, 12 to 15, 16 to 19. So I'm going to label that down below. So 0 to 3 is my one of my ranges for number of calls, then 4 to 7, then 8 to 11, 12 to 15, and 16 to 19. Okay, so we're going to have a bar that goes up to represent the frequency though. So the calls from 0 to 3 were 6 of them. So I'm going to come up and create a bar, and you can kind of see there's a tick mark here. Okay, so I'm going to go up to 6 and kind of fill that in. Okay, 4 to 7, we had 4, so my bar is going to go up to the 4 line. Okay, 8 to 11 was also 4. (12 to 15 was 3. And then 16 to 19 was another 4. Okay, so this is a histogram that represents the frequency at which these calls occurred. So it's asking which ones have the same frequency. We could either look here to get that information or look at which bars all go to the same height. So those ranges are from 4 to 7 calls, 8 to 11 calls, and 16 to 19 calls. Okay. Next, another example. Okay, so we have speed of cars. These have already been organized into a frequency table, and we're going to make a histogram using this. So this is going to be my y-axis, okay? And looking at my ranges, so I have a pretty small number up to 18, so maybe I want to go to like 20 or 24. You can kind of choose here. I might go to 20 actually. So I'm going to say frequency. Here, maybe I'll do this so it's easier to read. Okay, so on the y-axis, we're putting the frequency. And we want this to be, let's see, 1, 2, 3, 4, 5, 6. Ooh, but 20 doesn't divide nicely by 6, so I'm actually going to do 24 and divide each of these by 6. So then we'd have 4, 8, 12, 16, 20. Okay? All right. And then there's 4 in between each of those. So 1, 2, 3, 4, 4, Okay. All right, and then here's my bars. Again, there's kind of 4 different ranges here. So the first one is going to be from 50 to 59, 60 to 69, 70 to 79, 80 to 89. Okay, so to label this axis, these are the speeds. So we would want to label that axis as speed. And if you want, we could even add miles per hour. Okay, so again, we're going to create some bars here. So there are 2 people that got clocked going between 50 and 59. So here is 2. Then there's that bar. From 60 to 69, 14 people. There's my 14. Okay, from 70 to 79, there were 18. And 80 to 89, there were 3. Okay, so there's my bar graph or histogram. Okay, so now they're asking some questions about the data, saying how many people were going 70 miles per hour or faster. Again, we can use the histogram or the frequency table. So 70 miles per hour or faster would be these 2 ranges. So 18 plus 3 is 21. Okay, how many people were speeding if the speed limit was 60? Okay, so all those people were speeding, right? Definitely these guys, because these guys are all for sure over 60. So at least 21 people. But also, this category is not super descriptive. It just says they're between 60 and 69. So all these people could be speeding, or they could all be going the speed limit, or there could be some combination of each. But these people for sure are not speeding. So I cannot include those. So I could say at least 21 people, because we know those people are for sure speeding, and then maybe up to 35 if I add in those 14. But no more than 35. So somewhere between 21 and 35 people are speeding, but we don't know specifically what those exact speeds of the 14. So that it can be a downside to histograms is that because of these like ranges, we don't have an exact value. We just have a range that we know the data fits into. Okay. Another example here. Okay, so this time we already have a histogram, and we're going to use this to create a frequency table and answer some questions. Okay, so here we have the weights of players on the Washington Commanders. Use the data to complete the frequency table. So the first thing I like to do here is pay attention to the ranges, right? So this goes from 180 to 200. So that's what we call the bin width. So the bin width is 20, okay? All right, so between these 2 ranges, there are 2. All the way up here, this one's 10, this one's 9, 7, 4, and 2. Okay, so because they end right on here, I'm going to actually do between 180 and 199 pounds. Okay, so we have 2. I don't really have to tally here. Actually, we already know the frequency. Between 200 and 219, there are 10 players. Between 220 and 239, there are 9 players. Between 240 and 259, there are 7. And between 260 and 279, there are 4. And then our last one, 280 to 299, there are 2. Okay, so let's answer some questions. How many players weigh between 220 and 240? Okay, so between 220 and 240, that is this range, 220 to 239, there are 9 players. How many players are on the team? So all I have to do is add up all these numbers, right? Those frequency, and we get 34 players. How many players weigh 240 or more? So that'd be these last three ranges, 11 to 13. Okay, the commanders are going to assign a new player, predict how much he will weigh using the data given. Okay, so this is just where, what do most of them weigh? So most of the players weigh in these couple ranges, right? So 10 and 9 are super close. So maybe we would say between 200 and 240 are the most common weights. So that's predicting using that data, probably going to be within that range. Not saying it's for sure going to be, but if I were to guess, that's the most common weights. So that's what we're going to guess. Okay, so those are the histograms and how we can use frequency tables and answer questions. Next, we're going to look at a dot plot. So a dot plot also represents frequency, how often something is occurring. Okay, so we have games per World Series. So there's a bunch of different ones. Notice my different numbers, 4, 5, and 6. So what I'm going to do is I'm going to kind of draw a number line of sorts. We got 4, 5, 6, and 7 are our values. And we're just going to put an X for how many times they occur. So we can see there's 4 4s. So I'm going to put 1, 2, 3, 4. There's 3 5s, 2 6s, and lots of 7s. 1, 2, 3, 4, 5, 6, 7, 8. So this is a dot plot. It's just, again, representing how often something occurs. It's just another way to represent this data. Okay, we're going to also create a dot plot for this guy. Okay, so these are ages. So looking at my table, my lowest age is 41. My highest age is 68. So maybe my number line, I want to go from 40 to 70. Okay, so now we're going to put a X for every age. So we've got 41, 47, 50, 50, 50, 50, 52, 52, 52, 52, 54, 54, 62, 64, and 68. So that would be a dot plot to represent that data. Okay, another histogram example here. We're just going to use this to answer questions. So this one, I just wanted to show this one to you guys because we can have bars going out to the side as well. Same exact idea, okay? It gives us frequency and allows us to represent data in a very visual way. Okay, so this is library visits, so on days of the week, and these are the number of visitors that went on this particular day of the week. So on which day do they receive the most visitors? So we can see Saturday is the furthest out. They're closest to 300. So Saturday had the most visitors. Approximately how many visitors? So between, 290, 299, we're very close to 300. Again, that's an estimation, doesn't have to be perfect. Okay, why do you think that they had the most visitors? Well, again, this is just a prediction, but maybe it's because people don't work on the weekends, and so they had a chance to go to the library. So people are off work on weekends. Okay, how many visitors came to the library on Monday? Okay, so we're under 200. It looks a little further away from 300 than this one. So we said this one was maybe 290, so maybe this one's 180. Again, I'm just guessing, but using my graph to get a reasonable guess, a good estimation. Okay, describe a pattern you see from Wednesday to Saturday. So from Wednesday to Saturday, each day the number of visitors is going up. So number of visitors increases each day from Wednesday to Saturday. Okay, and then I want you guys to come up with another question that could be answered by looking at the graph. Okay, last thing here, you guys, is a stem and leaf plot. This is another way we can represent data. Okay, so what we're going to do is, and I'm going to add 2 more numbers here. We're going to add 105, you guys, and 121, because I want to show you what happens when we have those numbers. So include these 2 numbers in your data set. Okay, so basically what this is, so we have number of rushing yards completed by a running back on a professional football team in each of the regular season games. Okay, so we're going to say, I'm just going to say rushing yards. We'll title this. And then we're going to give it a key. So a lot of times, so all of these numbers are whole numbers, and the minimum we go to is the we have ones and tens place, and then actually we have something in the hundreds place here, which we're going to see that. And so what I'm going to do is I'm going to start with the lowest number, which for us is 32, and I'm going to put the 3 here in the stem. And then I'm just going to go right down the line, 4, 5, 6, 7, 8. So these are the tens place, right? 9. But I have a hundreds place, so I'm going to do 10. And then 120 is the biggest I go, so that's going to be my biggest stem. The leaves are all the numbers in the ones place. So 30, we have 32. There's no other number 30, so I'm going to cross that one. Okay, so now I'm on to my 40s. So I only have 43, so 3 is going there. Okay, 50. So we have a few 50s. So I just want to go, oh, sorry, I do have another 40. I have 48. So we're just going to space out the numbers, so how that happens. And we do want to go lowest to highest. So here, 43 and 48 are a number. Okay, now we're on the 50s. So we've got 52. We got a 54 and another 54. So we're going to list 4 twice. And then we have a 57. 60s, we got a 65 and a 68. 70, we have 72, 73, 74, and 78. 8, we have an 83. 9, we got 96, 98. We don't, 10, we're going to put a 5 for 105. We don't have anything in the 110s, 121. And then we give a key. So a key is, now how are these numbers broken down? So an example would be like key 5, 4 equals 54. So we're letting them know whatever's here is the tens place. This is a 1. But that's how it looks if we have hundreds. We just go an extra digit over in the stem column. All right, guys, that is it for this video. Thanks for watching.